So, two shadow problems, comparing 13 and 16, understanding the wording of the two a little bit more. On number 13, you have a street light that is 15 feet above the ground. So this is the light, ground level. And I don't know why they always have a man walking, but women walk too, but whatever. In number 13, we have a 6-foot tall human. They're walking away from the pole with a speed of 5 feet per second. And this problem is wanting to know how fast the tip of the shadow is moving. So I'm going to draw, well, whoop, there's 6 feet. When it asks how fast is the tip of the shadow moving, it's referring to this singular point. What is its speed? Now, the person, we are told that the person is walking at this speed. But realize that as you're walking, the angle from that light is coming, is changing. And so what you want to realize is the tip of the shadow is not moving at the same speed as this person. And in number 16, they talk about the length of the shadow. And it's really important that you see the difference between the length of the shadow, how fast is that growing, versus how fast the tip of the shadow is moving. So length of the shadow would be all of this right here. But keep in mind that the human there is moving. So a little bit later, the human is over here. Pretend that is a straight horizontal line. And can I draw a triangle? Okay. Here's the shadow right here. The length of the shadow is partly dependent on that person being in a different location. The speed of this point where the tip of the shadow is not dependent upon the location of the person. You want to anchor that to a point that is not moving. And then look at what is this distance's speed. And I'm going to put a variable then on these things. I'll use this other triangle. This is a definite 15 feet. This is a definite 6 feet. And I'm going to just use X and Y. I think those were the letters I was using yesterday. X being this distance and Y being this distance. If we want to know how quickly this point is moving, we want the rate of change of this entire distance to the pole. And how about we come up with a letter just to make it easier on ourselves? I'll use the letter Z. And I'm going to mention Z is X plus Y. But know that if you want to know the speed of this moving point, you need to know dz dt, not dy dt. And then if you look at the speed that the person is walking, you need to also have that fixed to a point that is not moving. If this person is walking at a rate of 5 feet per second, then the distance from them to the pole is changing at 5 feet per second. So that's dx dt. We want to find dz dt, and we are given dx dt. So we've got to figure out now what formula to use. And we have to use the fact that we have a pair of triangles that are similar. So I've got this right triangle and this right triangle. And does everyone see that those two triangles are similar to each other? We will be finding dy dt. We'll have to find dy dt in order to find the dz dt. So right now, just kind of stay with me here. I know how annoying this problem is because you're trying to figure out why the difference between speed of this point versus length of the shadow. And going back to the picture, I want to point out that the length of the shadow is affected by this person moving on top of this point moving. It's the two of them moving together that is making the length of the shadow change. But if I want to know how quickly this singular point is moving, I want to attach it to a point that is not moving and look at that distance. So I made a Z just to make it a little bit easier to look at these triangles. And I have basically my vertical to horizontal of the blue triangle is 6 to y. And on the yellow triangle, the vertical to the horizontal ratio is 15 to z. Now, I can put z or I can put x plus y. It's just a matter of what you're more comfortable with. It might be nice to temporarily just look at z and not have to deal with more than one variable sitting around. So just for starters, do you feel good with this equation? Maybe it's you don't see where the problem is going yet, but do you feel comfortable with this entire length is in a ratio with this length in the same way as 15 is in a ratio to 6? So the relationship of these lengths is all about the ratio of two similar triangles. So I'm going to cross multiply and have 6z equals 15y. And I now can do the derivative with respect to time. So derivative with respect to time, I have constant multiple 6 times dz dt equals constant multiple 15 times dy dt. Now, dy dt is how quickly the shadow is moving. dz dt is how quickly the tip of the shadow is moving. But what is it that I know? I know dx dt. So I've got to bring that into play. The rate of change of z is going to be the sum of the rate of change of x plus the rate of change of y. So what I'm doing today is I'm just trying to present the problem in a slightly different way as I did yesterday to see if that helps. So I'm going to put 6 times, and then dz dt, again, is the sum dx dt plus dy dt. Now, what we're going to be able to find is dy dt, but that's not going to be the answer. We need dz dt. That's going to tell me the speed of that point moving along. Now, dx dt is the rate at which the person is walking, which was, I believe, 5 feet per second. Yeah. So now I have 30 plus 6 times dy dt equals 15 times dy dt. And then I'm going to subtract the 6 dy dt over to the 15 dy dt to get 9 dy dt being equal to 30. Now, dy dt is the rate at which the shadow is moving. I need dz dt, and dz dt is equal to the sum of dx dt plus dy dt. dx dt is 5, and dy dt is 30/9. So this right here is giving me the speed at which that single point is moving. And I'm going to say again, the difference between the rate of change in the length of the shadow versus how quickly this point is moving, the if you want to know the rate of change of a particular point, you have to compare it to a point that is not moving if you want to find how quickly that point is moving. Because if you compare it to another moving point, you're not going to get the speed of the point you want. And so it's a matter of really looking carefully at the wording. Yeah. The shadow has a changing angle issue, but at any given moment, both triangles are sharing this angle, and that will hold the ratio of the vertical to horizontal. So that ratio is going to work even with this angle changing, because at any given moment, this relationship will hold. Now, I'm going to come over here and do number 16, and then we'll talk a little bit about the differences in wording. For 16, we have a spotlight on the ground shining on a wall that is 12 meters away. So we've got a wall, 12 meters. Here's the spotlight. And we've got another person walking. This time they are walking from the spotlight toward the building. And we have a speed. The speed of the human is 1.6 meters per second. And then we've got the spotlight shining onto the wall. Now, wording. The wording says How fast is the length of the shadow on the building decreasing? It is asking, what is the rate of change of this entire length of shadow? We've got that the person is 2 meters tall, but this distance is changing all the time. So I'm just going to put h for height, and that's got to have a variable. Then the speed of the person is going to affect the distance of the person to some stable point. Now, actually, in this case, both of these points aren't moving. You've got a choice. You can either say this distance is changing at 1.6 meters per second, and it's shrinking, so that would get a negative rate of change. Or you can say that this rate of change is positive 1.6 meters per second. As long if you've got a speed of a moving point and you want to basically change the speed into a distance changing, you've got to fix that moving point with a fixed point and then take that as a distance. And so in this case, you can use either of these two. I'm going to use the one that I know will be part of the ratio. So I'll just call this right here X, and I'll use another color. dx dt is 1.6 meters per second. And let's see, we are supposed to find dh dt. Now, just like the previous shadow problem, we have two similar triangles. So the ratios of little triangle to big triangle are the same. Little triangle has a vertical to horizontal ratio 2 to x. Big triangle has a ratio of vertical to horizontal being h to 12. And it's just a matter of keeping track of what is going to change in this problem and what is being held constant. Let's look at the two triangles that we got from the two different problems. The first triangle that we did had a fixed height of this light. This time, the horizontal distance is fixed. Both situations have a particular height of a person who is walking. And shadow problems always have that as a known length. Other than that, you're either going to know some horizontal length that is fixed or some vertical length that is fixed, and the other one is going to be changing. Both of them have their equations created by the ratios of those similar triangles. So kind of see the similarities and the differences. And a lot of times these problems are a matter of just reading them several times until you finally figured out what in the world it's saying. Now, this equation is just about ready. I'm going to multiply 12 times 2, 24 is equal to 8x times h. For this one, when I take the derivative with respect to t, I'm going to have to use the product rule. The other one I didn't because the equation I had the two variables on separate sides of the equation really nicely. So derivative with respect to time. Derivative of 24 gives me 0. And then I'm going to keep x multiplied by the rate of change of height plus keep the height and multiply by the rate of change of x. I'm given, now it's time for plug and chug. I am given 1.6 meters per second for dx dt. I am supposed to find dh dt. And now I'm going to have to figure out from the when information what are x and h. The when information, when the person is 4 meters from the building. So this distance right here is 4 meters. I need to know the length of x and the length of h. So if this distance is 12, then x is going to have to be 8, 12 minus 4. And now I've got to figure out h based on this information. And I've got, for my main triangle, let me see. So when I need to draw another triangle. At this point, my known values with the given are that this is 2 meters, this is 4 meters, this is 8 meters, for a total of 12 meters. And I'm trying to find h. So sometimes when you've got a picture, just setting it aside and redrawing, putting in all the information, then just step back and look at it. Do you see that we can find h using the ratios again? With the ratios, I have for my smaller triangle a ratio of 2 to 8 for the vertical to the horizontal, and for the big triangle, h to 12 for vertical to horizontal. And now I'm on my way. Woohoo! So 24 divided by 8 is 3. And that's going to give me my height. And now I'm all set. And I'll be able to find dh dt. So I realized that the wording is the issue that's confusing you more than anything else. Know that. And that's why you just have to do a lot of problems, because when tests come around, the test this Friday, as well as the AP test when it comes around, related rates show up. Often they will give a problem that is similar to one you've seen before. So the more problems you do, the better your chances are at figuring out what in the world they're trying to say. And sometimes you barely realize you are using related rates. And the problem just kind of comes out naturally. Okay, now, would you guys like to try a problem you haven't done as homework? Or should I keep going over problems you want to see? A brand new problem? Yeah. And this one's actually really good. Period 1 was happy. Find it. It was, I remember it was 21 because they were asking for 21 on a different homework page. and I didn't realize it. Come on. No, 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 no. No, stay there. Stay there. Why? I have so many problems with my computer not doing what I ask. All right. So, this is a good one. This is not simple. So, everybody, whole brand new problem. Although some people don't have their cameras on, so I don't know if they're even paying attention to realize this. Oh, the joys of online learning. Oh, yay, I see another person. Oh, you are? Good, 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 good. All right. So let's take a good read at this problem. We have at noon, ship A is 100 kilometers west of ship B. So ship A is located here, and it is directly west of ship B and is specifically 100 kilometers apart. Okay. I know some cameras aren't working. That's why I'm really excited about those Chrome tablets, or when you get them. Okay. Here we go. Ship A is sailing south at 35 kilometers per hour. Ship B is sailing north at 25 kilometers per hour. They're asking how fast is the distance between the ships changing at 4 p.m. The distance between the ships as time is moving is going to be this diagonal distance. Now, it might look scary when you first see the drawing, and you might be thinking, oh, do I have to deal with two triangles? Step back from the picture a little bit. Can you redraw it to simplify the situation? So I'm giving you a moment to think about it. Is there another way to draw this? Because I've got a set horizontal distance between the two of them. They're both traveling vertically. Are some of you seeing that you can make this just one triangle? So I'm going to make that singular triangle. Yep. A right triangle where the base, the horizontal, is 100 kilometers. And you might draw your right triangle slightly different than mine. It's just a matter of the relationship of sides and angles need to stay. Anyway, now I've got ship A and ship B together are causing a vertical change in distance. And what is the rate of change? I'm just going to call this H. Do we know dH/dt? Wherever they are they're vertically located in the same place, and then they travel north and south. From that fixed point, you have ship A is causing this distance to grow at 35 kilometers per hour. Ship B is causing this distance between itself and this fixed point That distance is changing at 25 kilometers per hour. So you're going to add those two rates together. And 35 plus 25 is 60. And I'll write 35 plus 25. And kilometers per hour. And we want to know the rate of change of this diagonal. Not diagonal, this hypotenuse. Oh, I already used H. I'll use C. And there are no angles that were discussed. You have one known side that is 100. You know dH dt, and you need to find dC dt. Do you see that the formula you want to bring out is the Pythagorean theorem? So Pythagorean theorem, we have 100 squared plus h squared equals c squared. That's the hardest part, is just figuring out what equation you need to use. So now we take the derivative with respect to time. For the constant, we get 0. For h squared, we get 2 bleh times the derivative of bleh with respect to time, and then 2 bleh times the derivative of bleh with respect to time. I can get those 2's out of the way. dH dt is known to be 60. And I need to find dC dt. I've got to figure out, how does the when information tell me the length of h and c? So they vertically had 0 distance between them at noon. We want to know the vertical distance 4 hours later. I know that h is changing at 60 kilometers per hour. So if 4 hours pass, then 60 times 4 gives me 240. And I believe this is one of the right triangle ratios. So I've got to find C using Pythagorean theorem or special Pythagorean triples. Does anyone have that number C? $260. And now I can plug those numbers in. So dC dt is going to be 240 times 60 divided by 260. And a little bit of calculations later, and what do we end up getting? Can someone tell me what we get on that? Okay. So 55.385. And what is that as if we leave it as a fraction? Or maybe we just need an answer. So we'll move on. I need to make sure to give you 10 minutes for your quiz so I can keep going for another 10 minutes. And I want to say again, today's Tuesday. Thank you. 720 over 13. We have both Wednesday and Thursday to continue going over any questions you run into. And I will work on getting videos made. So I need to make a video on 15 and 27. I need a reminder to myself about that. And to actually look at the reminder. And those are both related rates problems. Okay, what else do you want to see in homework for related rates? Yeah, we can go over physics particle motion problem instead. So is there a particular problem you want to look at or just generic? Oh, I have a bunch of numbers. Write those down. 16, 23, 28, 37. Okay. Has anyone gone on Khan Academy and done some of their related rates? Excellent. Good to hear. Okay, so if you want a physics particle motion problem, is there a specific one you had in mind? A new one. Let me think. You know, we never did the trig problem. Yeah, I think I know what you're talking about. That's it, actually what I was thinking. Just find. Come on. By number 3, you mean this number 3, right? And I don't believe I assigned it, but it's definitely a challenging problem. Will there be trig on the quiz today? I believe I did put trig on the quiz. Just the biggest thing with the quiz is read the problem carefully. You will find that the majority of your mistakes are not fully reading a problem. That and arithmetic. Okay, number 3. And I'm just basically going to go through and find like the variety of all of these things. Keeping in mind, we are dealing with t greater than or equal to 0 being the domain. And this is saying, so between 0 and 10 for time. All right, so let's get going. And by the way, if it's getting close to 10:40, you need to stop me. Velocity will be the first derivative. Derivative of cosine is negative sine. And then I've got baby function inside of cosine. So I realize I'm chain ruling, but I start with the mommy function's derivative. Then I go back to the chain rule, give mommy her baby, and I multiply by the derivative with respect to time of that baby, pi over 4. I've got velocity. Acceleration. To take this derivative, I'm starting off with already having constant multiple negative pi over 4. And I need to multiply that by the derivative of sine of blah. So again, baby function, derivative of sine is cosine. Then I remember that I'm chain ruling. And with chain ruling, I give mommy her baby and multiply by the derivative of pi over 4 times t. Now, you need to figure out what makes each of these equal to 0. So what you really want to do is start off with what are the angles that cause sine to be 0. So sine theta is equal to 0 for what angles? That's for cosine. Yeah. Sine is 0 when I'm at, and actually, no, hold on that. Let's just list, we've got like 0 pi, 2 pi, 3 pi, all that. cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, all the odd pi over 2s. Now the angle, however, is pi t over 4. So you actually want to set these equal to, if theta is pi t over 4, what is t when this is 0? What is t when this is pi? And so on. And I've got to make sure to answer all the t values that are between 0 and 10. So I'm going to make a number line and I'm going to put a 0 and a 10 on there. So this first equation is just giving me an endpoint, but the second equation is going to be 4. What? Okay, so I think you guys have it, you're talking with each other, figuring it out. Okay. For this one, when I solve for t and I multiply by 4 over pi, I get 8. And I feel pretty confident that I don't need to go any further than that. I'm going to go out of my range of being between 0 and 10 for t. For cosine, I need to do the same thing. I need to figure out if theta is pi t over 4, what is t to make that angle be pi over 2? What is t to get 3 pi over 2? And maybe we'll have to go as far as 5 pi over 2, maybe not. I'm going to make a number line between 0 and 10. And this first equation is solving, I get t equals 2. Okay, thank you. The second equation will give me 6, if I am arithmetizing correctly, and then 10. So there we go. Now, this is just part of it. I still need to figure out, like, when is velocity positive, negative? When is acceleration positive, negative? I've got to go back to the original equations and be very careful about the fact that I've got these negatives here, which means that normally right after 0, sine and cosine are positive, or actually they are, but because I'm multiplying by a negative, these are going to kick off with negatives. Then I will need to double check each of these intervals being positive or negative with their actual functions. And I am going to find that they go back and forth. So if the problem is asking when is the particle moving in the positive direction, that's time 4 to 8. And I'm just about needing to stop. If it is asking when is the speed increasing, then I'm looking at when are velocity and acceleration the same sign. They will be the same sign between 0 and 2. And then they are the same sign again when they are both positive, which is happening, let me see, between 4 and 6. Yeah, thank you. And then they are both negative between 8 and 10. So those would be my 3 intervals. I need to get that quiz going. But that's actually a really good reminder right before the quiz.